Hi everyone, welcome to this channel. The Mer- Hi everyone, welcome to this channel, the Merchant Construct-preneurs and Tutors. Today we'll be looking at a guide to proper reinforcement spacing requirements for beams. I look at the image here. You have your beam. Um, this is the beam standing, and this is the beam on the slides. So you are looking at these are the stirrups. Then look at the main bars, and we're just looking at that how to put our reinforcement, like the spacing that is required. So let's go through the introduction first. So introduction to rebar spacing. Rebar spacing is critical in beam design to ensure structural strength, proper bonding with concrete, and crack control. That is the major reason when reinforcement is being placed is to ensure proper strength, bonding with concrete, and crack control. Now, BS 8110 1997 Part 1 provides clear guidance on how to determine the correct spacing for rebars in beams to regulate minimum and maximum spacings for structural integrity. So when you proper spacings distribute loads evenly, right? Proper spacing distributes loads evenly. Here you have this spacing. It helps to distribute the loads evenly. Not that so it prevents sagging or any other. So everything is uniform, and then it helps to distribute the loads and then prevents cracks. So it allows sufficient soft concrete flow for compaction. So um also adequate cover is also protects reinforcement from corrosion, right? So typically rebar spacing ranges from 100 to 300 based on design needs. Like the spacing, you can have think you can still have like 100, 150, 125, just in increments of 25 from 100, 100, 125, 150, 175, 200, and till you get to 300, right? So depend on the design needs. There are some sections you will have that you need to use 300 some sections you have to use 250, some sections you have to use 200 depending on your design needs, right? So correct placement is crucial for constructing strong, durable, and efficient concrete structures. I hope we got this explanation. So let's move over to the next. Now, so the key requirements for reinforcement spacing. The key requirement for reinforcement spacing now from BS 8110, we have this. First, we have minimum spacing. For the minimum spacing, we have three conditions. Whichever is greater, the greatest of these three conditions is what we are going to use as our minimum spacing, right? We are going to check. So not less than the bar diameter. You have a value not less than the bar diameter. That is minimum spacing. Should not be less than the bar diameter. Should not be less than 25 and should be and again aggregate size plus 5 So if your aggregate size is 20 plus 5, that is 25 So whatever minimum spacing you are using, the greater or the greatest of these three conditions will govern. So for the second one, we have the maximum spacing, whichever is smaller. Maximum spacing, whichever is smaller. Now we have our 300 or 3 times the effective depth. Whichever is smaller will be the maximum spacing, right? So this might look confusing, but I will try to break it down so that we'll be able to understand the conditions. Okay, so this next one now we have crack control considerations. Now proper reinforcement is supposed to reduce crack width and enhances durability, right? Okay, so we have these conditions for crack control. We have whichever is smaller of 5 multiplied by the bar diameter or 300 whichever is smaller. That is what will guide the spacing for crack control. Okay, so to prevent excessive cracking, use just like a summary of it. Excessive cracking, to prevent it, use smaller bar diameter at closer spacing. rather than large bars at wide spacings. What he's trying to say is that, look at let's use this image. To prevent cracks, the spacing between the links should be closely packed, right? So when it is closely packed, it prevents cracks from forming, like visible cracks from forming, unlike when you use um bar diameters with wider spacings, right? So second is to ensure proper concrete cover, so to avoid corrosion and long-term deterioration. The third, provide secondary reinforcement, that is mesh in slab and walls to control shrinkage cracks. So this is talking about steel, because mesh is reinforcement, smaller size reinforcement like 6 mm, 4 mm, that are welded together, and the spacing, let's say like 50 mm spacing, so it's welded together like a mat, right? So to prevent crack, we also need to provide like a mesh reinforcement in slabs and wall to prevent shrinkage cracks. Then the next one is to use deformed bars instead of smooth bars. That's another one. Deformed bars instead of, so that we have a better bond with concrete, right? So we are looking at step by step calculation to explain what we mean by having minimum spacing or maximum spacing for a beam section with the given condition. Like, look at our data now. This is a beam section. We have 2 bars at the top and then 3 bars at the bottom with the links that is bold, and then the outer part of the section, right? Okay, so the beam width is 250. This is the section. Beam width is 250. The effective depth is 400. We have been given this already, so I believe we understand, we know how to calculate effective depth. Effective depth should be from the top here to the middle of this. Okay, so the clear cover is 30 mm. It's covered between this bar and this concrete, 30 mm. The bar diameter is 16 mm, so the bar diameter here, all the bar diameter bars, 16 mm. Also, the number of bars, we are taking this arrangement now. This is the highest side where we have the highest number of bars. At the top, you have only 2, here I have 3. So we want to know whether this arrangement, this 3, is sufficient. So I have number of bars equals to 3, right? Then the link diameter is 8 mm. This is the link, so it's 8 mm. So the solution, first we have to compute the available width. We are going to deduct from the total width to know the available width, and the formula is total width minus 2 times the clear cover. This is the cover to the reinforcement, cover to the reinforcement. That's why I have it 2 times, minus 2 times links. This is the link 1, this is the link on the other side, so 2 times the link. So total width as given here is 250 minus 2 times the diameter is 30 minus 8 mm links. So when you subtract this, you have 174 mm. I hope this is understood. So the next thing we have to do is to compute the bar spacing, and the bar spacing is given by available width divided by the number of bars. So the available width from what we calculated, 174 divided by 3, we have 58 mm. Now step 3, we want to confirm if it conforms with what we have from our BSc 2110 condition for minimum spacing and the maximum spacing, right? So for the minimum spacing, we said it will be greater of, we have 3 conditions: the bar size 25 mm or aggregate size plus 5 mm. Those 3 conditions, the greater of it, so that's for the minimum spacing. So the bar size is 16 mm, that's why I have 16 mm here. 25 mm, that's why I have it here. Then aggregate size 25 mm plus 5 mm. You're taking aggregate size as 25 mm. So the greater of these 3 is 16, 25 and 30 is 30 mm. So that's why I have 30 mm here. That's the minimum spacing. Then for the maximum spacing, we have a lesser of 3 times the beam effective depth, or 300 mm. Now the beam effective depth is what? 400 from what we were given here. Effective depth 400. So we have 3 times 400 is 1200 mm, or 300 lesser of it. So between 300 and 12, the lesser is 300 mm. So come to a conclusion that since 58 that we got from here is spacing falls within this limits of minimum and maximum spacing, the design is acceptable, or the arrangement is acceptable. Hope you got this. So that is how we look for that. So in conclusion, proper rebar spacing is essential for strength, durability and crowd control in beams. Following BS 110 Part 1 1997, it ensures compliance with structural safety standards. So key takeaways to remember what we have done: minimum spacing is greater of bar diameter 25 mm, aggregate size plus 5 mm inside the conditions. Maximum spacing is lesser of 300 mm or 3D, which is the bar diameter. Then sorry, let me correct this. Greater 3. Then tension zone, this is what we have: 5 times the bar diameter for crowd control. So you also ensure proper cover between 25 mm to 50 mm. I believe we have been able to cover and understand the arrangement of bars should be within the limits, minimum and maximum limits. For more information about structural engineering, calculations and construction, please subscribe to this channel, the Merchant Construct-preneurs and Tutors. See you in the next video. Bye.